thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, thank you for tuning in to the Concentrator Talk call brought to you by the Oxygen Alliance. I'm your usual host, Mwai Lungu. Very pleased to be hosting the call today. I am joined by my colleague, Cynthia Chikomoni, along with our usual technicians from OpenO2 and Sunrise. On the technicians panel today, we have Paulina Mohosho and Masofa Mojaji joining us from Johannesburg, South Africa. We have Kowinda Singh joining us from Chandigarh, India. And we have Kelvin Saidi, Daphne Magela, Linda Mishoni, Eunice Msiska, and Mphatso Kalumbu, who is also a new technician joining us for today. In case this is your first time and you are not aware, the Concentrator Talk Call is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. And here we discuss the different aspects of concentrator assessment, use, and maintenance. So if you have any troubles with your machine, we always encourage you to send those questions to us in advance, and then our technicians will do their best to come up with the right solutions for you. During the call, we normally have polls at the end of some of the questions, so if they pop up, please do attend to them. And as we normally do, we'll also have a topic of interest. And today, we'll start discussing on a series which will take us a couple of calls. Today, and then we'll finish it in our next talks. If you have any questions during the call, you can always raise your hands or just come off mute and ask that questions. So I'll also be pasting the questions in the chat. So in case you miss them, you can also pick them up from the chat. All right, let's now dive into our questions for today. So our first question says, how can the compressor operating voltage be tested? So I am going to ask Masofa to respond to this one.
Thank you, Mwabi. The compressor needs an input voltage in order for it to operate. If the compressor does not start when the concentrator is turned on, the input voltage has to be tested to find what's the problem. You need a voltmeter to do the test. If not, you can use a multimeter or test light instead. Currently, the most used devices for testing voltages are multimeters. To test the input voltage using a multimeter, connect the concentrator to a power source and turn it on. Turn on the multimeter and set it on AC voltage 500 as shown in the graphics. Connect the red lead to the multimeter to the brown wire and the black lead of the multimeter to the blue wire on the compressor connector as shown in the graphics. If no power is found, check for loose or damaged wire between the compressor and the connector and switch or wire harness. If the compressor connector shows voltage, either the capacitor or the compressor may be faulty. Thank you, Moi.
So it seems Maui has lost connection. So I'll just read the second question. And it reads, I am a technician working on a NATEC oxygen concentrator. I found that the Flowmeter bore is not going up as I keep on adjusting the Flowmeter knob. I did what I could to see if my connections were okay, and all connections seem to be okay. What am I missing to get the concentrator working? I'll ask Linda to take this question.
Thank you, Kelvin. Considering the fact that the Flowmeter bore is not moving up, that simply shows that the connections are not okay. So you have to check if the sieve beds are able to release pressure when tubes are disconnected at the exhaust point. If the pressure is not coming out, know that there is either a blockage in the sieve beds or in the valves, or there is a disconnected tubing inside the unit. So to solve the problem, you can start by tracing the tubing from the compressor exhaust point up to the flow meter. One of the common problems associated with the new tech oxygen concentrator model is the disconnection of the blue tubing on the area labeled in the image, as shown in the graphics. Due to movements or vibrations, the labeled area gets eaten up and then it is cut off on its own after some time. As seen in the figure above, the blue pipe is disjointed. So the solution is to this problem be to find another new pipe with the same diameter and replace the broken one. After doing that, you see that the airflow has been restored and the machine is back to normal. Thank you. Over to you, ma'am.
Thank you very much, Linda. Sorry, I lost my connection somehow for a minute there. If we have any questions or comments from the other technician, we are free to ask those questions. Or if we have any questions from the audience, we are also free to ask, and then Linda can clarify where necessary. And as we are waiting for those questions, we have a poll at the end of this question, and I'm going to launch that poll. And our first poll says, have you ever worked on this model of concentrator before? So I'm going to leave the poll open for a few minutes and then we'll see the responses from the audience. As for me, I have never worked on this model before. This is new to me. Okay, our votes are in, and it seems most of us haven't worked on this type of model. So I guess this is a pretty new model for a lot of us. And yeah, I hope if we encounter a similar issue, we will know where to pick up from next time. All right. Okay, we have a hand from Michael. Go ahead, Michael.
Thank you, Mark. So about also, I just want to ask a question because I've also experienced this situation where the indicator ball does not go up while adjusting the flow meter knob. And I noticed in my experience that also when the output port is blocked by chance, also the ball does not move up. It in fact remains at the base of the flow meter. I don't know if this is true for everyone, but this is what I experienced too.
Thank you very much, Michael. Indeed, that is true. I have actually also encountered that issue before, but for the concentrator that I was working on, it stayed idle for a long time. So it happened that some insects built a nest on the patient's outlet port. So tried to switch it on, adjusted the flow, nothing was happening. So yeah, that's true. That can sometimes happen. And if the solution that Linda suggested doesn't work for you, then try to go for Michael's solution, and I'm sure it will solve your problem. All right. I don't know if we have any further questions there, or we can proceed to our next one. Okay, no question. So we'll jump on to our next question now, which says, hello, I am a biomedical technician at a certain organization. I was working on a Devilbiss 515 oxygen concentrator, and I noticed that the product tank was leaking. I was thinking of replacing the product tank with a product tank from a Devilbiss 525 concentrator. Can this be appropriate, and how can it affect the performance of the oxygen concentrator? So just to clear things out here, so they are working on a 515 and the person is trying to replace the product tank with a product tank from a 525. So I'm going to ask Paulina to respond to this one.
Thank you, Mabi. Okay, so during the oxygen concentrator operation, after the pressure swing absorption process that happens in the sieve beds under pressure generated by the compressor, the oxygen produced is directed into the product tank. So as airflow switches between the two sieve beds, there are fluctuations in oxygen purity that occur. The product tank allows for oxygen from both sieve beds to mix inside it, which helps to maintain steady oxygen purity level of the oxygen being produced by the concentrator before it is delivered to the patient. So in addition, it also acts as a buffer to stabilize any pressure difference between the sieve beds. The product tank is connected to a pressure regulator, which is used to reduce the high pressure coming from the sieve beds to a lower pressure, which can be delivered to a patient. The pressure of about 0.5 bars, which is 8 psi, and this pressure varies depending on the model of the oxygen concentrator. The Devilbiss 515 and the Devilbiss 525 oxygen concentrators are different. The compressor, sieve beds, and product tanks, just to mention a few components used in Devilbiss 515 concentrators, are larger compared with those used in a Devilbiss 525. So their operating capacity is different. Replacing a 515 product tank with a 525 product tank is not a good idea. These two concentrator models use two different compressor models. The Devilbiss 515 uses a ZW370 compressor, which has a maximum output pressure of 102 psi. On the other hand, the Devilbiss 525 uses a ZW280 compressor, whose maximum pressure is 73 psi. In addition to all of that, the sieve beds pressure of these two concentrator models are different, with 515 sieve beds having higher output pressure than those of Devilbiss 525. This implies that the pressure in their tanks are also different. If you put a 525 sieve bed in a 515, it will fill up with oxygen faster, which might result in pressure buildup in the sieve beds. This will in return cause the relief valve on the compressor to start popping, and if you have some other pipes which are not strongly fitted, they might become disconnected also. Furthermore, to all that information, different models of oxygen concentrators are designed to accommodate oxygen tanks of different sizes. In your case, it can be easy to mount a Devilbiss 525 product tank in a Devilbiss 525 concentrator, but this will not guarantee a high oxygen purity. If you do it the other way around, it may not work as you may expect, because it might not have enough space to accommodate the big product tank. Therefore, I would advise you to seal the leakage with epoxy if perhaps the metal casing is broken, or you can use a thread tape if you have a leakage in the joints. If not, then scavenge another product tank of the same model and do not interchange, as this will affect the performance of your concentrator. Thank you, Mavi.
Thank you very much, Paulina, for that response. I hope that explanation was very clear and that will help you to solve your problem. So try out the solutions that Paulina suggested, and if you don't get any changes, then you can always get back to us and then we'll see how to help you further. So if we have any questions or comments from the other technicians and the audience, we are free to ask those questions and make those comments. Okay, since we don't have any questions there, so we'll now move on to our next question, which says, I am a biomedical engineering student in my second year of study. We are currently on holiday, so I decided to learn more about different equipment and how they work. This week, I have been researching on oxygen concentrators. I have been having difficulties understanding how the compressor used in the oxygen concentrator works. Can someone help me understand how this component of an oxygen concentrator works? So I'm going to ask Kelvin to answer this one.
Thank you, Maui. So there are different types of air compressors, and they're used in different applications. So there are two main categories of air compressors, and this is based on their internal mechanisms. So these categories are the positive displacement compressors and the dynamic compressors. So from these categories, we have some common types of compressors, and they include the reciprocating compressors, the rotary compressors, you have centrifugal compressors, and axial flow compressors. So oxygen concentrators use the reciprocating air compressors, and these are a type of displacement compressors. So the way these types of compressors work is by reducing the volume of air, and this increases the pressure. So this is achieved by the reciprocating movement of a piston within a cylinder. So most compressors used in oxygen concentrators are double-headed, and they have two pistons. So as one piston is moving up to push the air out of the compressor, the other piston moves down to create a negative pressure in order to suck air from the surrounding environment. And the piston rod is mounted to an eccentric bearing assembly, which is attached to the motor shaft. So the linear movement of the pistons is brought about by the rotation of the rod assembly. The linear movement of the piston, which is brought about the rotation of the rod assembly, is not as steady as the pistons tend to wobble. So in order to compensate for this and increase the compressor's efficiency, the compressor has cylinder sleeves and piston caps, which are used to form a tight seal and act as a mechanical guide for the piston. So you should note that the compressors which are used in concentrators are oil-free, so you should not use a lubricant when working with this. So the image in the graphics shows the cylinder sleeves and the piston caps that are used in these types of compressors. I hope that helps you. Thank you. Over to you, Mark.
Thank you very much, Kelvin, for that explanation. Indeed, I hope that's going to help them. But if you still have any further issues, you can always get in touch with us, and then we'll do our best to try and suggest more solutions for you to try out in order to fix your problem. So if you have any questions or comments from the other technicians or from the audience, we are free to ask those questions. Right, it seems we don't have any questions there, so we'll be moving on to our next question, which says, I am a nurse at a certain district hospital. This week, I was using a Devilbiss 525 oxygen concentrator to administer oxygen therapy to a patient whose prescription was 5 liters per minute of oxygen. I adjusted the Flowmeter knob to the end. After a few minutes, the service required light was activated, accompanied with an audible alarm. I decided to use an air-safe 10-liter concentrator, which was not being used at the time, and I took the Devilbiss to the workshop. Later on, the concentrator was brought back to the ward, and they said nothing is wrong with the concentrator. What could have triggered the alarm? So I'm going to ask Linda to take this one.
Thank you once again, Mal. All oxygen concentrators are equipped with alarm systems whose function is to alert the user if something goes wrong in the unit. Therefore, it is very important that all medical personnel should be aware of the alarms of oxygen concentrators so as to prevent connecting a patient to an equipment which has a fault or is not set properly. The alarms which are incorporated in oxygen concentrators, as explained in one of the topic of interest in one of the concentrator talks, include the low oxygen purity, power failure, high or low pressure, and high temperature alarms. So the link for this particular call will be shared in the chat. And apart from the alarms that I have just mentioned, the Devilbiss 525 also has an oxygen flow alert. When the Flowmeter is set below 0.5 liters per minute, the continuous service required LED accompanied by an audible alarm is activated. This alarm is also activated to indicate high flow when the Flowmeter knob has been turned all the way up to the end. In this case, the float inside the Flowmeter will move up to the end of the Flowmeter, that is to the top wall of the Flowmeter, exceeding the red line on the Flowmeter. Since you have said the maintenance personnel informed you that the concentrator was performing well, and during the setting up of the unit, you turned the knob up to the end, then it implies that the alarm was activated to alert you that there is high oxygen flow being delivered to the patient than what was prescribed. When setting up the flow of an oxygen concentrator, you should always pay attention to the flow rate labeling on the Flowmeter to avoid this from recurring. Some oxygen concentrators may not alert you when the maximum flow value of a concentrator has been exceeded. So make sure that if a patient is prescribed 5 liters per minute of oxygen, you should set the Flowmeter to exactly 5 liters per minute and do not exceed it. Because once you have exceeded the 5 liters per minute, it means you are giving the patient more oxygen than they need, so it may result in some complications. In addition, as I have already pointed out about the low flow alarm in Devilbiss 525, I would like to recommend that if you want to administer oxygen therapy to a baby of flow rate and that is below 1 liters per minute, you should use another concentrator model whose flow meter can be adjusted to uh, below 1 liters per minute. So in the graphics, that's the flow meter for the Devilbiss 525 or any other Devilbiss concentrator. So when adjusting the flow meter, you shouldn't exceed the 5 liters per minute flow rate, and also shouldn't go below 0 to prevent the alarms. Thank you, Maui.
Thank you very much, Linda, for that explanation. That's well detailed, and I'm sure that has answered all your questions that you had. I also encountered I've ever encountered a similar problem before. I was working on a 525, sorry. We fixed it, took it back to the ward, and then the nurse immediately brought it back saying, no, when I switch on the concentrator, all the lights are turning on. So I just switched it off immediately. So just explain to her that normally for the 525, when you switch it on, all the status alarm come on and then they turn off, and then yeah, if you have any issues, they start turning on thereafter. But when you just switch it on for the first time, all the status lights turn on. So for some, they are not quite conversant with these status lights and how they behave. So thank you very much, Linda, for giving us that explanation. If we have some questions or comments from the audience, they are very welcome and we can make those comments. Okay, it seems we don't have any comments there. So we'll now take a slight diversion from our questions, and we'll jump on to our topic of interest. And as I explained at the beginning, today we'll be talking about how to troubleshoot the different common problems in oxygen concentrators. So this is a very long topic, so we have decided to split it into two parts. So we are going to cover the remaining parts in our next concentrator talk call, and we'll upload the series on our website, so you will be able to follow through properly. So I am now going to hand it over to Eunice, who is going to take us through.
Thank you very much, Maui. So as Maui has already said, today we're going to talk about troubleshooting common problems in oxygen concentrators. So I'll cover the first part of this edition. So oxygen concentrators are among the most dependable and effective pieces of life-saving equipment used to offer oxygen therapy in patients. So basically, these patients are those that require respiratory assistance and supplemental oxygen. So these machines are designed to run continuously if necessary, but they should be given a 20 to 30 minute break after about 7 to 8 hours of continuous use to prevent the problem of overheating. So oxygen concentrators have a number of parts which work hand in hand in the production of highly concentrated oxygen. So with time, these parts wear out and stop working properly, hence compromising the performance of the oxygen concentrator. Therefore, there is a need to replace or service these parts. In order to identify which part is faulty so that it can be replaced or serviced, a thorough troubleshooting process is required. So in our topic today, we'll discuss about troubleshooting these common problems. So there are several common problems that we encounter, and these include low oxygen purity, high pressure, low pressure, and power issues. So in this part, we're going to cover low oxygen purity. So low oxygen purity is one of the major problems that we encounter as technicians when we're dealing with oxygen concentrators. So the most important thing you need to do is to check for the oxygen purity using an oxygen analyzer, as the oxygen sensors built into the oxygen concentrators may fail sometimes, and this might give you a wrong picture of the performance. You also need to check the number of hours your concentrator has been running. So you can do this by reading the hours on the LCD of the oxygen concentrator that you are working on, or the Holtz meter of the concentrator. So this varies depending on the model of the concentrator. So if your concentrator has been running for a lot of hours, then there are high chances that your compressor kits have been worn out or the zero rate has been degraded, as these parts are designed to function effectively for a specific number of hours. For example, for the compressor, it must be serviced after about 5,000 hours. So there are several causes of low oxygen purity, and one of the causes is leakage. So you need to check for any leakages in the unit, as this will give passage for oxygen to escape, resulting in low purity. You can check if the unit is leaking by covering the outlet of the flow meter while the concentrator is running. So if the ball goes down and does not float, then there is no leakage. But if it floats, then there is a leakage. So you do this before you open your oxygen concentrator, just to be sure that there are no leakages, or if they are there. So you need to, after you see that maybe your ball is floating, so you need to open the oxygen concentrator and check for these leakages. You can use soapy water to check for leakages in pipes or joints. And if you see bubbles, then there is a leakage. So you need to seal these leakages if you want to get a high purity. So seal these leakages where necessary, either with epoxy, or you can tighten the fittings with thread tape. And where necessary, please replace broken pipes with new ones. The compressor is also another part of the oxygen concentrator that leaks sometimes. And this happens if the screws are not well tightened, and also if the gaskets or O-rings are worn out. So these leakages will make the necessary compressed air for the pressure swing adsorption process to escape. So if you have done whatever I've just mentioned, and if you are sure that there are no leakages, then you can now check for the output pressure. Oxygen purity is dependent on the output pressure of the compressor. So the compressor supplies the necessary compressed air to the seedbeds for the process of pressure swing adsorption. The necessary pressure produced by the compressor is about 30 psi, and this varies depending on the model of the oxygen concentrator that you are working on. If the compressor is giving out the output pressure less or more than the required pressure, then the absorption process will not be effective. So you need to check for the output pressure using a pressure gauge that will be connected to the exhaust of the compressor. So the compressor should run independently and observe the pressure. So in order to obtain the maximum pressure the compressor is producing, you should remove the relief valve and close the port with a hex plug. And once the maximum pressure has been obtained on the gauge, you can now compare that pressure with the manufacturer's data sheet and see if it tallies. Graphics, please. So in the graphics, we've shown you the compressor, and the arrow is pointing where the relief valve is normally located, and we have removed that relief valve and we have put a one-way valve and inverted it so that we can obtain the maximum pressure. So that's the gauge connected to the output port. After you have obtained the gauge, then you compare it with the manufacturer's data sheet. And if it's the pressure that the data sheet says that you should get, then now your compressor is good. But if the pressure is less or more than the required to be produced by the compressor, then that means the pressure absorption pressure is compromised. And in some cases, the compressor will produce a squeaking sound, and this is very common when the kits are worn out, and this will lead to low oxygen purity. If the pressure is below the specified pressure in the data sheet, then you can now service the compressor. After doing that, you can check for the compressor output pressure, and if it's the right pressure that is required, then you can place it back into the unit. Another thing to consider is the output pressure from the patient outlet. So every oxygen concentrator has an output pressure at which it operates to give out the required oxygen purity. So you need to use an analyzer or a pressure gauge to check for the pressure to see if it's the right pressure. So this pressure is determined by the pressure regulator. So every concentrator has a pressure regulator. So if the regulator has been set to a pressure above or below the recommended level, then the oxygen purity will be compromised. So check in the manual of the model that you're working on. Check in the manual for the output pressure of the concentrator you're working on and adjust the pressure regulator accordingly. If the rotary valve sometimes or the solenoid valves are not switching properly, this will also affect the feeding and wasting cycles. So if these cycles are compromised, then the pressure swing absorption process will also be affected. So if you see that there are variations in the cycle, maybe when one bed is being fed and the other is not being fed, or you notice anything strange, then you need to check your valves if they are functioning properly. Also, if the orifice necessary for the equalization pressure is positioned wrongly or maybe it's broken, the oxygen purity will also be affected. So you need to check also your orifice if it's in the right condition, and also if it's in a good position. So another cause of low oxygen purity are faulty one-way valves. So another important factor to consider are the one-way valves. So one-way valves in oxygen concentrators allow air to only flow through it in one direction. So these valves prevent backflow of air when there is back pressure building up in the system. So there are several valves in the unit, and these valves include flapper valves that are found on the valve plate of the compressor, one-way valves located between the final bacteria field and the outlet fitting of the compressor, and also one-way valves between the product tank and the sieve base. All these valves are there to make sure that oxygen is oxygen is actually going in the right direction to avoid any fluctuations. So one of the signs of faulty one-way valve is fluctuation of oxygen purity. When you test it maybe with an oxygen analyzer, you're going to see fluctuations, and sometimes it actually give you a very low purity, and there are high chances that your one-way valves are either broken or they have erupted. So you need to check for this. So how can we check for this? You can check the performance of one-way valves by blowing in air on both sides of the one-way valve and see if air is only blowing in the direction of the arrow. So one-way valves will have an arrow that will point the direction to which the air is supposed to be going. So as you can see in the graphics, the picture is showing us the one-way valves. Another important thing that also causes low oxygen purity is degraded zeolite. So if you're still getting low purity after doing all the things that I've mentioned, then there are high chances that your zeolite has been degraded. So an oxygen concentrator has sieve beds that use molecular sieves called zeolite. Zeolite granules are a synthetic aluminum silicate that binds nitrogen molecules and lets smaller oxygen molecules pass through. But unfortunately, it has the ability to absorb water, which can cause problems, especially in areas with high humidity. So zeolite tends to lose its filtering capacity over time. When moisture enters the sieve beds, the zeolite swells up, clogs the zeolite, and oxygen can no longer pass through. And this will lead to low oxygen purity. So, as you can see in the graphics, as you can see in the graphics, you can see how that zeolite is looking. It has lumps, and the way it is like that in the graphics, it cannot be able to effectively bind the nitrogen. So you can check the seabed pressure to see if the pressure is the required one. So this is the pressure for the adsorption process. The cycle pressure ranges from 25 to 30 psi depending on the model of the oxygen concentrator. So you can check this by connecting a pressure gauge at the output of the seabed as shown in the graphics. As you can see, the gauge is connected at the output. So while the concentrator is running, you're going to see how much pressure is being let out by the seabed. So if the pressure is more or less than that designed for that seabed, then there's a high chance that the zeolite has degraded. So when your zeolite has degraded, there's nothing you can do for now. So you need to refill that sieve bed with new zeolite that will be able to absorb nitrogen and let oxygen to pass through. So after you have done all these things and maybe you are still getting low oxygen purity, or maybe your compressor is sounding an alarm of low oxygen purity, then you also need to check for the oxygen sensor. So the oxygen sensor measures the proportion of oxygen in a gas. So if your concentrator is sounding, for example, an alarm for low oxygen purity, and you test it with an oxygen analyzer, maybe it's showing you a high oxygen purity, or maybe it's varying, then your oxygen sensor is probably 40. So you need to check for this sensor, and it is mainly found on the board. So check for continuity and also how much voltage it is receiving. If it is not continuous, or maybe there is no voltage coming to it, then there's a fault. As you can see in the graphics, we're using a meter to check for the continuity, to check if all the wires are connected properly. And if you see that your sensor is 40, I would encourage you to replace it if you have any spare oxygen sensors, or if maybe they are not there and you have spare boards, you can use those boards. So that's what I had for you in part 1 of troubleshooting common problems in oxygen. Thank you.
Thank you very much, Eunice, for that explanation. I'm sure we have picked up a lot. So as I explained, this is a series. We have a couple more things to share with you. So please don't forget to tune in to our next couple of calls so that you follow through. All right, if we have any questions or comments on what Eunice has just presented, we can ask those questions or make those comments if we have any. Right, it seems we don't have any comments there. Okay, so thank you very much, Eunice, for a wonderful job. And we'll now jump back to our questions. So our next question says, I was working on a J5 oxygen concentrator that was brought to the workshop because of low purity. I refilled the sieve beds and I was able to get a purity of 95.6%. But I have noticed that the flow rate displayed on the analyzer is different from the one set on the Flowmeter. Is it okay to leave it like that since the purity is 95.6, or should I rectify the problem? If that is the case, what can cause this and how can I solve this problem? So I am going to ask Daphne to respond to this one.
Thank you, Maui. So, an oxygen concentrator draws in atmospheric air, then passes it through molecular sieve beds to increase oxygen concentration to therapeutic levels before delivering it to the patient. The World Health Organization provides guidelines for the safe administration of oxygen. Some of the areas they focus on are oxygen purity and flow rate or flow control, depending on the patient's age and condition. The WHO guidelines state that oxygen concentrators must be equipped with at least one built-in flow meter with flow rate control. It is important that the flow delivered to patients be adjustable and accurate because oxygen flow needs change throughout the course of treatment and is especially important for premature born babies or neonates because excessive oxygen therapy causes harm. So yes, even if the purity is high, it is important to make sure the flow is accurate because patients are treated at different flow rates depending on their age and clinical condition. The flow rate produced by the oxygen concentrator depends on the outlet pressure. For the J5 oxygen concentrator, outlet pressure range is 5.8 psi to 10 psi, and this means that the flow meters were designed to operate within this range. So the problem you have encountered may be due to a lower or higher pressure at the outlet of the oxygen concentrator. If the pressure is high, that is, it is above that range, the 5.8 to 10 psi range, a higher flow rate than the one that has been set will be displayed on the analyzer and vice versa. So you can also measure the output pressure using an analyzer or a pressure gauge in order to determine the outlet pressure. There are many causes of pressure changes, and these may include leakages, blocked sieve beds, and faulty solenoid or rotary valves. So please check all of these and make sure that they are functioning properly and correct any faults or problems identified. If all these are checked and are functioning well, the problem may be with the pressure regulator. In this case, adjust the pressure regulator until the outlet pressure is within the ranges specified in the manual. If the regulator is damaged, replace it with a new one. Over to you, Mari.
Thank you very much, Daphne, for that wonderful explanation. I'm sure if you try out the solutions that she has suggested, you should be able to solve your problem. But in case that doesn't work for you, you can always reach back to us and then we'll try to suggest further solutions for you to try out. So we have a poll at the end of this question. So I am going to launch that poll. So our next post says, have you ever encountered a situation where the oxygen analyzer flow rate did not match the flow meter's flow rate? So I'm going to leave this open for a few seconds and then we get people's responses. And as we are waiting for those responses, if we have any questions or comments regarding with regards to Daphne's suggested solutions, please, you can make those comments or ask those questions if we have them. Okay, so our votes are coming in, and from the looks of it, most of us have encountered these problems, and it is a very common problem. So I'm sure for those of us that have ever encountered this problem before, we now know how to get around it. But if you haven't encountered a similar problem before, then if you just try out the solutions that Daphne has suggested, you should be able to get around your problem. All right, so we still have a few extra minutes before the hour mark, so we'll move on to our next question, which says, hello, I am a biomedical technician at a certain hospital, and I was working on a 10-liter air syrup concentrator. I wanted to know about solenoid valve coil replacement. Can you explain more on how I can do this? So I will ask Kelvin to answer this one.
Right. Thank you, Maui. So solenoid valves are used wherever fluid flow. So in our case, the fluid is compressed air. So solenoid valves are used wherever fluid flow has to be controlled automatically. So these are control units, so which when electrically energized or de-energized, they either shut off or allow fluid to flow. So the solenoid valve coil takes the form of an electromagnet. So when energized, a magnetic field builds up which pulls a plunger or a pivoted armature against the action of the spring. When de-energized, the plunger or the pivoted armature is returned to its original position by the spring action. So if the coil is defective, then your valve will not operate. An ohmmeter can be useful, a useful tool in determining the condition of the valve coil. So when you're using an ohmmeter in the New Life Intensity 10 unit, the valve coil readings should be as indicated below. So if your unit is a 120 volts AC unit, the equalization coil should read about 1,000 ohms with a tolerance of plus or minus 100 ohms. And the feed or waste coil should read about 850 ohms with a tolerance of plus or minus 85 ohms. If your unit is a 220 to 240 volts AC, the equalization coil should be about 4,300 ohms with a tolerance of 430 ohms plus or minus. And the feed or waste coil should have a resistance reading of 3,100 ohms with a tolerance of plus or minus 310 ohms. So you can determine which coil is not operating by checking each valve to see if it becomes energized during unit operation. So to check for coil operation, you need to follow the steps below. Firstly, you have to remove the plastic cap that secures the valve coil to the valve stem. Do not remove the coil. So with the unit operating, hold a paper clip or a metal tip of a screwdriver slightly over the top of the valve stem located in the center of the coil. When the coil becomes energized, that is, it has been magnetized, the paper clip or the tip of the screwdriver will be pulled down to the valve stem. This will indicate that the coil is operating. But if the coil is faulty, it will not become energized and it should require replacement. If you're using 115 volts, if you are working on 115 volt unit, if the solenoid valve coil does not operate, its corresponding green light on the circuit board does not illuminate. So to replace a solenoid valve coil, you need to follow the steps below. You need to set the unit's inputs or output switch to the 0 position and disconnect the power cord. And then remove the side and back panels of the unit. Remove the red cap with a slotted head screwdriver. Then disconnect the power wires to the valve and lift off the solenoid coil. Then you have to replace with a new coil. Then press the red cap back on top of the coil and reconnect the power lines. Then reconnect back the side panels as shown in the graphics. I hope that answers your question. Thank you. Over to you, Mark.
Thank you very much, Kelvin, for that response. I'm sure if you try to follow the steps that Kelvin has suggested, then you should be able to get around the problem you're facing. If you still have any further challenges with swapping out the solenoid, then you can reach to us and then we'll see how best to help you. If we have any questions or comments from the audience, please, you are welcome to make those comments, or you can just come off mute and then make the comment. Okay, it seems we do not have any further comments there. So reaching this far, this now brings us to the end of our call today. And I would like to thank you all for joining us for today's call. And before we jump off, I have a special announcement. So next week, we will not be having our normal questions and answers, but instead we'll be having our monthly constant oxygen talk. And this is our final oxygen talk of the year. So please make sure that you are available for that call, because as I explained last week, we'll be having a guest speaker from AirSep. So if we have any questions with regards to AirSep oxygen concentrators, this is our best chance to ask those questions directly from the manufacturers. So please put it on your calendars and make sure that you are available for that call. And for those of you that haven't shared with us your contact details, please do so in the chat so that we can add you to our mailing list. And this will help us to send you frequent reminders of the next concentrator talk course. And if we have new materials, we also send out updates through the emails. If you happen to have missed any of our previous calls, we do happen to record all our calls. So if you go on YouTube and search for Oxygen Alliance, we have a YouTube channel there. And there you should be able to find all the previous oxygen concentrator talk calls and the oxygen talks that we have had. And that should help you to catch up from there. We also have a website where we post different content. And if you want to learn more about the Oxygen Alliance, all the information that you need is also posted on our website. So reaching this far, I would like to wish you a great weekend, and I hope to see you during our oxygen talk in this coming week. Have a great weekend and goodbye.